What is up, Derek with 13 Series Engineering here, and today we are going to be going over our next phase of development and kind of the plan for that, the next stuff we're going to be looking at. I know we still have a lot of stuff to do with login, auth, and registration, but we're going to put that all on the back burner. It's basically built out. We just need to do like verify your email address, reCAPTCHA, and finish the reset password stuff. That's all stuff that we just have to do before we get into DevOps basically, or before we go to production. So it is just kind of getting tedious, and I'll definitely do a video on all that stuff, but we're just going to take a quick break from it and get into our next phase. Super important. We're kind of going to be going over, actually making this more of a single page app other than just navigation. We're going to be doing, WebSocket and, live data and all that stuff. That's really the strength of any single page app is, taking that browser rendered, server-side rendered markup and making it act like a desktop app would, like actual MVC, where stuff, we haven't really done any MVC stuff yet. We haven't, other than changing navigation, changing our views, we haven't, had interactions with models through a controller that update a view and all the users get to see it. So we're just kind of talking about the plan for that today. Basically, the example we're going to use is our parts table because it's pretty simple. We're going to create a part, and there is an image component to a part, but we're going to skip over that and come back to it later and probably do a video about like just uploading image compression using an S3 bucket, or I don't even know if AWS S3 has a free tier, but we're going to find whatever free tier bucket service we can for image upload and go over that. But we're just going to focus on the basic form submit. Again, all server-side rendered, all Symfony form stuff, form builder. You create a part, it gets displayed in the parts table here, and essentially when you do navigate to the parts table, it will show that part there because it is getting that markup and getting that data from that endpoint from the server. But let's say you're just looking at the parts table and someone made a part. You're not going to know that that happens till you navigate away and then come back. Again, you're not going to have to refresh the page, so that's great. But in order to improve that functionality, or you see a part like pop into it, basically we're going to use a turbo stream for that, which turbo streams are like Turbo's WebSocket implementation using turbo stream tag. It's really simple. I've actually never done turbo streams on like a production level app, but I have done it with personal projects before. Turbo stream uses Mercury Hub, so essentially it's WebSocket. There's some really cool ways you can configure that. It's super easy. Essentially Turbo does all the JavaScript for you. So again, it's literally just a Symfony controller and the stream tags and a template. You need a template that gets rendered in. So super easy. So that is one of the things we're going to be doing probably in the next video, is going over turbo streams and how all that works, so we get actual MVC. And then the other thing we're going to be doing in later videos is we're going to be doing a notification system with Kafka. So we'll have like a notification pane right here next to our view. I have to excuse my crude drawings, but we're going to have like an alerts like drawer. We'll use like a bootstrap drawer and like some badge that will update with new alerts that you have. And we could just use turbo streams for that, or WebSocket, or anything. But we're actually going to use a Kafka stream, which is something that I think a lot of people haven't been exposed to, but it's really catching on in the industry because there's a lot of upsides to Kafka, a lot of advantages that you don't get in WebSocket. Like, for example, when a consumer connects to the broker cluster, you can go and tell it to reread commit IDs, reread messages from like a time frame. So like 24 hours prior, or since the last login, or the last 10 minutes, or not reread anything, just reread from right now. In that case, it behaves like a true WebSocket. But there's a lot of really cool things you can do with Kafka that give you a huge advantage out of the box, as opposed to turbo streams or WebSocket or any of that. So normally you wouldn't do this. You would probably like pick one of these and go with it. It's okay to have both of them. It just complicates things. but we're doing this just for the sake of a tutorial. And I'm actually going to do something I've never done with Kafka before, which is Kafka, well, we can just draw this out probably. Just kidding. Just do a really crude, quick drawing. So Kafka has a, gosh, that's tiny, a broker cluster. Typically that's 3 brokers, but it could be, you know, like a bunch. Those brokers work like your hub in WebSocket, like Mercury Hub. That's your WebSocket server, okay? So that's where messages come into and then get distributed. The thing is, the messages don't actually get distributed from the broker cluster, and that's what makes Kafka different. The other components we have is producers and consumers. So a producer will not subscribe, but it will connect to the broker cluster for a set topic. So the topics they're just named topics. In our case, it will be like new part created or something like that. When a new part gets created, we're going to produce a message, and that message is going to go onto the broker cluster, and it's going to have a ID, and it's just going to get the next ID that's available from the broker cluster. So we have our broker cluster, we have our topics on our broker cluster. For us, it's new part created is the topic. I think they're called topics in Turbo Streams as well as like any WebSocket. It's kind of a universal thing. And then you're going to have consumers, and typically, you know, you're going to have more producers than consumers, but not always. You know, you could have one consumer for one producer. Just depends. In our case, though, the consumer is not going to be GraphQL or Node or some other backend service. It is actually going to be the browser, the client, which that is something you can do with Kafka, but it's not typical. A lot of times you don't connect clients from a web browser as consumers. But what happens is that consumer is going to connect to the broker cluster, and it is going to have an ID in mind of what it wants to start reading from, a number. And it might be the most recent ID, like so don't reread messages, or it will be 0, so reread every message, or it'll be some place in between where we've determined you know, where it should reread messages from. And this is going to use Kafka JS as a dependency in order to do this. Now, Kafka JS has a lot less power, a lot less features than a lot of the server-side Kafka libraries like librd Kafka, and there's an important reason for that. It's made to be lightweight and have less config options, so it just does the basic things you need it to inside of a browser. We're not trying to download a huge dependency into a browser to do all this stuff. And you know, if you're using Kafka JS in like GraphQL or Node, you're going to realize you're going to run into some issues, some roadblocks, because you know, there's going to be some bugs because there's config stuff missing that you can't add because it's just not part of it. So really the best thing to do is Kafka JS is like just for client-side browser JavaScript. You know, if you are using Kafka to be received like in a GraphQL or Node endpoint or something else, you need some type of intermediary library to like do that. You should use like you should spin up a Java project or PHP or .NET or something else to like receive those messages off the cluster and then send them to a Kafka JS endpoint, kind of like a you know, a way to sanitize these messages, because if you're just using Kafka JS, you can have some issues connecting that consumer to the broker cluster. But anyways, that is literally what we're going to do is we're going to connect Kafka JS consumers to our broker cluster, and we're going to receive messages in a WebSocket like way. It is a cool way to do that, but what's going to be different about anything that I've ever done, or different than anything I've ever done, is that when we produce messages, we're going to base 64 encode them. That's pretty standard. You don't have to do that, but it is standard to kind of save on, you know, the data stream, the bandwidth. But when parts get created and we create our producer messages, we're actually going to produce a markup. We're going to render a twig, and that's going to be our message. Like I said, I've never done this before. There might be some nuances to getting it to work, but we're going to render like it's going to be like notification twig. So we're going to render this out. We're going to JSON encode it. We're going to base64 encode it. Well, we might not need to JSON encode it, but we're going to base64 encode it, and then that's what is going to get sent to the broker cluster. And then the consumers will read that message. They're going to base64 decode it, and then they're going to have markup that just gets injected, and it's going to be a really small amount of markup, but it's going to get appended to our notifications pane over here. So the cool thing about that is, client side, you don't have to render or use templates to do client rendering. It's basically just going to show up as HTML already rendered out, and it just gets appended to this, this div that's going to be our alerts drawer. So it should make it super easy. It'll be an Axios controller. The consumer connects to the broker cluster, reads from whatever ID. When it gets a new commit ID, it just takes that message, decodes it, and literally does like inner HTML, like appends the markup in there, and that's all we do. So it should make the client side really, really easy, and it should be pretty easy to do on the server side too. You're just rendering a twig and passing it as the message body. But that's essentially what our plan is for the next phase of development, to kind of get all the data, all the stuff to come alive, so parts and things are working, and then we're going to go from there as far as rounding out other things and making it, adding the features that we want. We're going to add some cool graphical stuff to actually build your ship and build parts, and then there will be permissions involved as far as like, who can edit a part. You can only edit parts you create, and doing all that stuff using firewalls, using Symfony user objects to show who has permission to do what, and making sure that that can't be like fudged or hacked in some way, that you could just go edit parts when you shouldn't be able to. So just some added security and permission stuff there. And well, this will really make it come alive, really make it feel like a single page app, and give you the ability to do all these things for everyone to kind of interact with each other. And maybe we'll even put like some group chat or some chat room in there as an option, because that's the cool thing about TurboStream. It's a great advantage for it is, and that's actually the advantage they use in their docs, is like a group chat room. So yeah, well, of course we'll use like your captain name for that, and it'll be pretty cool. A lot of stuff we can definitely add. But let's start making this behave like a game. It's really amazing the stuff you can get done in a web browser nowadays, and it's just amazing. Like, why would you do any executable or native application when you can do this? It's accessible to anyone. Anyone can run this. Like, as long as you can have Chrome or Firefox or Edge, you can run this app. You can run it on your phone. It's responsive, so huge advantages there. But basically, this is just our next phase of development, things to make this act more like a game. And I know we have a punch list of stuff that needs to get done. Probably create that here just so we don't lose track of it. But these are things that are kind of essential, like for a fully functioning app that looks professional. I'm sure everyone's been to a website and there's no 404 pages. It's just like an actual browser error page or different things like that. So that's we need 403 pages too. We need, what else? Verify email before you can log in. That's going to be lengthier in code, but it's going to be pretty simple. It's some pretty basic logic and displaying messages to a user. Not hard at all. It's just going to take like a full day of work to actually get that done. Probably just going to record bits and pieces of it. This will be super long. Reset password. We just need to finish implementing that. Remember me token, that's like literally one line of code to do that. Wow, I can't spell anything. But still needs to be done. reCAPTCHA token, we definitely need that implemented just for registration, not for login. And then upon registering and verifying your email, we might want to add like a Stripe integration that you have to pay like $1 or something like that, because why not? It'll keep the spammers out of there if you actually have to give credit card information. Stripe's an awesome thing to use. It's super easy to make like custom pay stuff, but this would probably be like a video series on its own to like add Stripe, because there will be several parts to it. It'll get pretty lengthy. What else do we got here? We got a QA form errors, like for registration. I think login's probably good with its errors. Autocomplete's not working. That's another one to fix. Not broken. Autocomplete is broken. It's not working. Autocomplete broken for everything. Gotta figure that one out. I haven't really had any time for it. QA for responsiveness, because I know some of our divs don't fold correctly. And then the other thing we want to do is we are starting to get a buildup of Sass. We're probably not going to add a ton more. And compared to other things, I've worked on stuff with like 10,000 plus lines of Sass, and we did end up adding entry points to it, but it's not something we did right away, and it was fine. But adding entry points will definitely help. The thing is, like, most of the Sass is just used globally, so we're probably gonna have a lot of Sass for like build a ship or some of those, and I know I'm gonna add a bunch for the view parts table. So maybe those are 2 entry points we want to, consider adding. The thing is that when you switch back and forth is when you switch views, you're not doing a page reload, but that's when you need to load up additional Sass. And once it's loaded, you can't unload it. But it's just like, depending where you log in, maybe for like build a ship, because that's not the first thing you look at. Like build a ship, we're going to want to add an entry point for all the Sass for that. And there will be a lot of JavaScript for that too. So that's a good idea. We'll do entry points for build a ship. That should be the only one, because you go to build a part or view parts kind of initially. Oh, maybe we'll have it for both of them. Webpack entry points for build a ship, and we'll do it for all 3 that aren't the main view that gets loaded up. Build a ship, view parts. We probably don't need that for create a part because it'll be too light. But this is also more just to prove a point. It's really easy in Symfony to do entry points for JS and for Sass. And you just save a lot of page load speed. Not that ours is slow. We're delaying our page load to show our rocket animation. So, obviously we have all the time in the world, but just for fun, just to put less load on the browser. And maybe you're logging in, you're just going to build a ship. You're not going to, look at the parts table or create a part. It's just stuff you don't have to load. So it's a good practice. It's a good thing to kind of go over. I feel like it's missed a lot of times in single page apps, and that's why that initial page load is so long. Not only is it because of requests and data, but it's also because a ton of JavaScript and a ton of Sass is getting loaded that isn't needed. You should have an entry point to split that into different areas. It's just something that it's like one of those web dev like boot camp, like it's a code boot camp trick, to make things faster. But that stuff's important. Sometimes you need a good mesh between like these little web dev tricks and actual engineering. And so that's kind of the point of this video series, by the way, is to find that mesh between, hey, these are little front end code tricks we can do to make things look cool, and here is some actual engineering to like back it up, and that we're not just covering up a bad architecture. We're using a good architecture, and we're using these tricks together to give a really amazing user experience. So yeah, that's kind of the plan for things. Next video, I will be going over TurboStream, setting up a Mercury Messenger Hub. All really easy. The docs in Symfony are super straightforward, and we're just using it to append rows in a table for creating a part, which is going to be a form submit in a turbo frame. So too easy. All right, that's all we got time for today, but we will definitely talk soon.